Okay, ladies and gentlemen, this is over writing equations of lines. Notice on this first graph, you're only given 2 points. Well, at those 2 points, you need to find the slope. So rise over run. So down 2 to the right 5. Use the y-intercept and the slope in order to come up with the equation line. Remember, it's y equals mx plus b. That's slope-intercept form. Standard form, remember, it's in the ax plus by equals c. So you're given 2 points. So from 2 points, you can get a slope. So it's a rise of 3 over 1. You're also given the y-intercept. Well, you can put it in y-intercept form, but then you have to change it to standard form by doing uh, the following steps. Number 3, you're given a slope and a y-intercept. Go ahead and put it in slope-intercept form, but then let's go ahead and get rid of the fraction. We're going to multiply everything by 2, and then we're going to move the x over. And when we do that, I get x plus 2y equals 12. So therefore, that's standard form. Remember, standard form has x is positive. It's on the same side as y. It always comes first, and there's no fractions. Number 4, you have a slope of 1/3 and passes through this point. Well, because we have a slope and a point, we're going to use point-slope form. Plug in the features. We're going to distribute the 1/3, and then after you distribute, you're going to move this 2 over. Use your calculator in order to add these together. And you get y equals 1/3 x plus 2/3. Notice we want it in slope-intercept form, so basically we're done with this problem. On number 5, slope is undefined. Remember, if it's undefined, it's going to be up and down. It's going to be an x equals. So that means it would be from this point to this point. I just chose this point just randomly. So between this point and this point, the rise is 4, but the run is 0. Therefore, it's undefined because you cannot divide by 0. That's how I knew that this was an up and down equation. All right. Number 6. Number 6 gives me a slope in the x-intercept. Well, I just basically drew a little graph to show me where that point would be. And I know it's going to go this way. So what I did was I used a point-slope form, plugged in those points and the slope, and got out of it y equals 1/2 x plus 8. All right, and that's what I wanted. I wanted it in slope-intercept form. On the back, number 7, you're given 2 points. Go ahead and find the slope, y2 minus y1 over x2 minus x1. So 5 minus a negative 1, negative 2 minus a negative 4, and you get a slope of 3. Choose one of these 2 points, it doesn't matter which one, and you're going to put it in point-slope form and solve for y. On number 8, you're given 2 points again, except now you're going to put it in standard form. In this instance, 5 minus 5 gives you 0, so therefore you have a 0 slope, because 0 divided by negative 10 is 0. Plug that into y equals mx plus b, and the only thing you get is y equals 5. Y equals 5. All right, number 9, which is parallel. Now notice on number 9 and number 10, one is parallel, one is perpendicular. They were using the same equation. So I'm going to solve it over here, and I get y equals 3/4 x minus 2. Since it's parallel, I'm using the same slope. I'm then going to use this point, and I put it in point-slope form. Now, I'm solved for y, and I get down to this answer right here of y equals 3/4 x minus 27/4. You want to multiply all 3 terms by 4 to get rid of the denominator, and you get 4y equals 3x minus 27. Notice I subtracted the 3x, move over here, I got negative 3x plus 4 equals negative 27. I multiply everything by negative 1 and get 3x minus 4y equals 27, which is in standard form. Now, for the perpendicular, remember your perpendicular slope has to be the negative reciprocal. Over on this one, the slope was 3/4. Well, if I have a slope of 3/4, the negative reciprocal is going to be negative 4 over 3. So basically what I'm going to do is I'm going to use this slope, my new slope, and this point, because it passes through this point. Put it in point-slope form and solve for y. All right. Now, on number 11 and number 12, I use these 2 points. Now notice when you have tables, you can find the slope by doing change in y over change in x. So 0 minus a negative 2 is positive 2. 6 minus 0 is 6. Or actually, to get from 0 to negative 2, you subtract the 2. And then to get from 6 to 0, you subtract 6. So basically I have a slope of 2 over 6, which is 1/3. I basically have this slope, which is 1/3 x, and I use this point, which is my y-intercept. So 1/3 x minus 2. I just kind of plug this into here, and I use this, and I plug it in right here. I then want to put it in standard form, so I multiply everything by 3, and I get 3y equals x minus 6. You got to move the x over, and then change the sign of everything inside by multiplying by -1, and you get x minus 3y equals 6. Over here, did sort of similar things. I basically did, what do I get, or how do I get from -18 to -8? Well, you add 10. How do I get from 3 to 1? Well, you subtract 2. And then 10 divided by -2 is -5. I then chose the easiest point I could find. Out of all these points, this was the easiest to work with, to me. So I chose y minus -8 times your slope times x minus 1. And basically I solved for y. And I wanted it in slope-intercept form. All right, your next page is a continuation. A couple of things. When you're given something in standard form and you're asked to graph it using the intercepts, remember, an x-intercept is x0. A y-intercept is y0. So if you plug in 0 for y, you're left with 3x equals 15. And x would equal 5. So you basically would have a point 5, 0. And that's what I did. I plotted it at 5, 0. Same concept here, except you plug in 0 for x. When you plug in 0 for x, you want to find out what the y value is going to be. And in this case, 5 times 3 would give me 15. So my coordinate point is 0, 3. And you just connect the lines. Over here, graph equals y equals 2. We just covered that in class. Remember, it's this way. Y is equal to 2. So I just drew a line where y is equal to 2, and these are all a couple of points that are on this line, or 3 points to be exact. My slope in this case is 0 because the change in y is 0. There's no up and down, but the change in 1 could be, or the run could be change in 1 for every point. Number 3, I solve for x. It's the only variable I have. There is no y. So I kind of know it's going to be an x equals. But when I solve it, I get x equals -4. It's a vertical line of x equals -4. On the back, we're going to put all of these 3 points in standard form. Actually, all 4 of them in standard form with the given information. So I'm given 2 points. Find the slope. Up 5 to the left 2. So up 5 to the left 2 gives me a negative slope of -5/2. I decided to use the point -2, 0, and I put it in point slope form. I then solved for y. I eliminated the denominator by multiplying everything by 2, and then solving, or putting both the x and y on the same side, which gave me 5x plus 2y equals -10. Number 5, you're only given 2 points, so what can you do? Well, you can do change in y over change in x and find the slope. Once you do that, you use point slope form, again, to solve for y, and then move the x over, and then multiply everything by -1 in order to get 6x minus y equals -1. Number 6, you're given a slope and an intercept. Remember, x-intercept is the coordinate point 2, 0. So again, point slope form, solve for y, get rid of the denominator by multiplying everything by 5, and then make sure you get x and y on the same side, and then multiply everything by -1. The last thing, remember, it's perpendicular. So I find the slope by solving for y. My slope is 2. Remember, the perpendicular slope to 2 is -1/2. Use this slope and this point, put it in point slope form, solve for y, multiply everything by 2 to get rid of that denominator, and you get x plus 2, and you get 2y equals -x minus 12. Add x to both sides, and you get x plus 2y equals -12. And that will conclude your notes for this lesson.